MOONS is the multi-object optical and near-infrared spectrograph. It is an instrument we are currently building here in the UK at the UK ATC, which is going to go to the VLT, the Very Large Telescope in Chile. So there's the multi-object bit, that's the front half of the instrument that collects light from the telescope and looks at lots of different objects, around about 1,000 objects all at the same time. And then the other half of the instrument, the optical and near-infrared spectrograph, that's the thing that's just behind me, and that's the bit where we take all that light from the telescope, from those galaxies, from the stars, put it into our instrument, spread that light into a spectrum, and that's what we then analyse to understand how old the star is, what the star is made from, how fast it's moving, kind of get all the information that we're interested in.
Multi-object is the key thing that you see right behind me. It's 1,000 optical fibers that are automatically located in targets of interest. That's what opens an immense amount of discovery space over what you're doing in terms of observing different types of either galaxies or stars. And when you look at their properties in these large numbers, at the same time you can start finding specific things that you have not seen before if you look at only a few tens of them. Now, that's the multi-object part, and then the other critical part of it is that we're able to get the spectral of them, so we collect the light from these fibers. This goes through these fibers into the spectrograph, where we disperse the light into different wavelengths, both covering at the same time the optical light to the infrared light. MOONS has one scientific question. We can simply summarize the objective of MOONS on why we're building MOONS to understand galaxy formation and evolution throughout the entire history of cosmic time, the entire history of the universe. That is the main objective we want to do. To do that, you need to do different things, different areas that you need to focus on. We can, on one hand, do it in our galaxy, what we call the local universe. And in our galaxy, we're going to be focusing on the centralmost parts of the galaxy. These are the regions of the galaxy where you have bars, where you have what we call the bulge of the Milky Way, and you have many different substructures of the galaxy that in their properties, or better said, the properties of the stars that are there, will allow us to then reconstruct the different processes that have happened and how the galaxy has been formed and how has it evolved, how has the Milky Way interacted with its surrounding environment throughout its history. We need to have the infrared wavelengths there in order to go through the amount of dust that we have sitting between the Earth and the central parts of the galaxy. That's where the infrared parts come in. And we need high spectral resolution. We need to be able to resolve very well the individual features in the stellar spectrum in order to recover the chemical signatures of these stars and the way that they're moving, their velocities, something we call radial velocity, the stars moving back and forth from us. So we need to measure all of these properties, and that's what it allows us to then reconstruct the history of the galaxy. And then if we extend this throughout the history of the universe, we go to high redshift, to the high redshift universe, there's a specific epoch of the universe where galaxies were forming the majority of the stars. This is a very active part in terms of the galaxy evolution. You cannot observe the features, or better said, the features in the spectra, in the optical light, in the local universe at low redshift. They move, because of redshift, they move into the red, they move into the infrared wavelengths. Those are the wavelengths that MOONS is focusing on covering. And therefore these parameters, so the wavelengths it covers, has been fine-tuned so that we can map the features of the galaxies in this key epoch of the universe, what we call cosmic noon.